Hello and welcome back. Today we'll be talking about something called the dot product. In a previous video, I explained how multiplying a scalar by a vector gives us a vector as the product. But what if I told you now that if you multiply a vector by another vector, you actually get a scalar? This is called the dot product. Now, how does this work? Let's say we have two vectors, a vector b and a vector a. And let's say we want to do the dot product of a dot b. The dot product multiplies the magnitude of a and the component of b that's parallel to a. Let me show you what that looks like. The section I labeled b cosine theta is the parallel component of vector b to vector a. So, another way to write a dot b is a b cosine theta. Both a and b represent magnitudes here, and b cosine theta is the parallel component of vector b to vector a. AB cosine theta is what we call the dot product. And notice that it is also a scalar. The angle referenced in cosine theta is the angle between vectors b and a. Now, the definition of the dot product is heavily reliant upon the angle between the two vectors. So, let me show you a few examples of what happens when this angle is changed. Let's say the angle is 0 degrees. What does that mean? Well, it means that vector A and vector B are actually parallel. Since cosine 0 degrees is 1, we can write the dot product as being simply AB. Now, let's say the angle is 90 degrees. Or, in a different way, the vectors are perpendicular. Now, you may notice that there's actually no component of the vector b that's parallel to a. So what now? Well, this means that our dot product is actually equal to 0. And you can mathematically find that out by plugging in cosine 90 into the AB cosine theta equation, and cosine 90 is 0, so you will always get 0. Now, one last example. What happens if the angle is greater than 90 degrees? For example, this vector A and this vector B have an angle between them that is obtuse. Well, this gets a little interesting because the parallel component of vector b is actually behind vector b. Since this is the case, the dot product is actually going to be negative. This is because any cosine of an angle greater than 90 ends up being negative. Now, what if you don't know the angle between the two vectors? Well, there is another way to calculate the dot product using just the values of the vector. Let's say vector A is equal to x1, y1. And vector b is equal to x2, y2. Another way to solve for the dot product of two vectors is to take their x components, multiply them together, and add them to the y components multiplied together. And as you can see again, this will give you a scalar. Let's do a quick example of that. Let's say vector A is equal to 3, 4, and vector B is equal to 1, 2. Now, let's solve for A dot B. Well, we'll take the x components and multiply them together, and add that to the y components multiplied together. This ends up with 3 plus 8, giving us a dot product of 11. Thank you for watching, and I hope this was informative. Happy learning!